Hi, I'm Alex, and today I'll talk about non-convex min-max bilevel optimization for task-robust meta-learning with Songta, Perry, and Lilly. We consider the standard bilevel optimization setup, minimizing f of x and y star of x, where y star of x is the argmin of g. One algorithm to solve this is called TTSA, which converges an O of k to the minus 2/5, k being the number of iterations. F is weakly convex and g is strongly convex, which will be the case we consider here. A common application of bilevel optimization is in meta-learning. However, with the standard formulation, the classifier will do well in the average case, but in the worst case, it may perform poorly, which is a problem in few-shot multitask facial recognition, meaning that the classifier is worse for some races than others. One mitigation is called task-robust mammal, where they optimize for the worst-case loss instead of the average loss. Our goal is to try to formalize task-robust mammal and give a generalization. We'll first do this by considering multiple loss functions instead of just one, each one representing one task. Next, we'll do the same thing with the overall loss f, where instead of just minimizing one overall loss, we want to minimize the worst case loss over the different tasks. In total, we will have n tasks, and again, we consider the same setting. Our formulation also generalizes task-robust mammal for this loss. Now I'll talk about the algorithm. Before we go over the specifics, one thing to note is that maximums are hard to optimize over, and therefore replace the maximum with a weighted sum where lambda is on the simplex. Therefore, we end up with this problem. Our algorithm to solve the problem is called Taro-Boba. Let's go over this in more detail. First, for each of the tasks, we'll do an inner optimization step on y, doing gradient descent on g. Next, we'll consider the outer optimization, which consists of two steps. One, a gradient descent step to minimize over x, and a gradient ascent step to maximize over lambda. We note that when n equals 1, our problem reduces to standard bilevel optimization, and our algorithm reduces exactly to TTSA. Similarly, our algorithm will generalize task-robust mammal for this inner function g with a full batch size. Next, let's look at convergence. We achieve a convergence rate of square root n k to the minus 2/5. N is the number of tasks, and k is the number of iterations, for y, lambda, and x. We note that TTSA converges in k to the minus 2/5, and TR mammal has the same rate as we do. And so therefore, Taro-Boba recovers both these convergence rates. While not the focus of our work, preliminary experiments on sinusoid regression show that our algorithm is superior to standard training. First, we proposed a new framework for robust meta-learning. We then proposed Taro-Boba to solve this problem, and gave a theoretical guarantee to generalize previous approaches. However, we lack a thorough empirical evaluation. We wonder if the convergence rate can be improved, and finally, we're always happy to find new applications of our framework. Thank you.